So hello everyone, my name is Jade Hott, and today I'll be giving the mini workshop on industrial cybersecurity training and education standards, getting the water to the end of the row with CYBERCHAMP. So here's a agenda for today's presentation. First, I'm going to go over a little bit about me, my background. Then I'm going to give a brief overview of the state of industrial cybersecurity, going to define the problems and solutions that we're going to focus on in today's presentation, getting that water to the end of the row. The proposed solution, which is the Cybersecurity Competency, Health, and Maturity Progression Model, CYBERCHAMP for short. And the CYBERCHAMP model has a job task analysis, which we are going to focus on today because the model is very large and we only have a short time. So part of what we use to build that job task analysis tool is the NICE framework. And then I'm also going to give a demonstration on that and finish up with how you can use that job task analysis to develop and implement individual learning paths. I'm going to end with a few minutes for Q&A. So please hold your questions till the end. You can put them in the chat. I will address them during the Q&A. So a little bit about me. I was awarded my Bachelor's of Arts in Psychology from Idaho State University. I currently reside in Idaho. I actually take a human factors, industrial organizational approach to cybersecurity. I'm an early career researcher at Idaho National Laboratory. My job title is a business specialist for the National and Homeland Security Training Office. I've also included my contact information here, so I have my email and also my LinkedIn profile. So if there are any follow-up questions or you just want to chat after the session, please feel free to use that information. So what is the state of industrial cybersecurity? So here I've put together some interesting statistics. One of the ones that I thought was the most interesting is how long it takes approximately to identify a cybersecurity threat and then how long it takes to contain, respond to that threat. So there was a study that in 2019, it took approximately 206 days just to identify the cybersecurity threat, another 73 days to contain it. So we're looking at almost a year to get a cyber threat under control. So I think that definitely points to an education gap. Another interesting statistic is how overwhelmed cybersecurity teams are. 62% of respondents in a survey said that their team was either significantly or somewhat understaffed. So that points to the pipeline problem in cybersecurity. So I'm sure we're all a little bit familiar with that there are millions of jobs open in cybersecurity and they're just remaining unfilled. So we have to get more people into the field as well. An interesting statistic from my point of view is that 95% of cybersecurity breaches are caused at least in part by human error. So that can be because adversaries or attackers are taking advantage of human vulnerabilities instead of system vulnerabilities. So some of the tactics are called social engineering. So they prey on those weaknesses with a variety of methods. One of them is a phishing email. So you may receive an email that looks legitimate, looks like it comes from a trustworthy and viable source, and the goal is to get that person who receives the email to click on a link or an attachment that can provide a backdoor or opening into a system for the cybersecurity attacker. Another really interesting stat, especially because our world has changed so much since COVID-19, is that since the start of COVID-19, the FBI reported a 300% increase in reported cybercrimes. So we're seeing that these attackers are unfortunately taking advantage of the situation and attacks are just increasing. So I'd like to go on to define the problem and solution a little bit more, getting that water to the end of the row. So you may be wondering, what does it mean to get the water to the end of the row? It's actually a farming analogy. So a row is when you have kind of a plowed area of land, an indent, and the goal is to use that to get the water to the crops. So we can think of, in this analogy, cybersecurity as the crop. So a very healthy cybersecurity program, a wealth of knowledge on cybersecurity and the ability to anticipate and prevent those threats. So what we're seeing is there's a lot of obstacles in getting that water to the end of the row for cybersecurity. These can be those system vulnerabilities, it can be human vulnerabilities, And something that I'm going to touch on a lot today is the competency of individuals in that workforce. So what is the general problem? The general problem is that the threat landscape in industrial cybersecurity is just constantly evolving, while at the same time, the need to have that competency cybersecurity ready workforce is just increasing. So where does education come in? That's with standards and curriculum that's up to date. Right now, to my knowledge, there is no standardized curriculum for industrial cybersecurity. So that's something that we really need to take a look at. Education and training to competency at that individual level, and helping to build the workforce pipeline alongside industry. So why CyberChamp? What does this model do? So the CyberChamp model provides an organization the ability to build those clear education, training, and learning pathways at an individual competency level. When I refer to an organization, I'm not just talking about like an industrial sector, could be academia, it could be training organizations, so they can all take advantage of this model that was built for many stakeholders. So a little bit more about CyberChamp. So CyberChamp is short for Cybersecurity Competency Health and Maturity Progression Model. CyberChamp informs academic institutions and training providers on those educational gaps. And then by discovering those gaps, that offers a unique opportunity for targeted apprenticeships, targeted degree programs, anything that you can do to fill that market need. And what we're focusing on today is that job to task analysis tool, which was built as part of CyberChamp. We believe that this job to task analysis tool can be used to reverse engineer the education and training offerings that are provided for cybersecurity by job role. So this tool was built based off of the job roles and tasks listed in the NICE framework, which I will go into a little bit. And we also, because the NICE framework is typically focused on IT roles, so information technology roles, we also included some industrial operational technology roles in a separate industrial security framework. So what is the NICE framework? The NICE framework is composed of 7 cybersecurity workforce categories. Categories are listed here on this model: investigate, collect and operate, protect and defend, analyze, operate and maintain, oversee and govern, and securely provision. So within each of these 7 categories, we have specialty areas and work roles. Specialty areas are those distinct areas of cybersecurity work, and the work roles are those detailed groupings of ITS of IT tasks for each role. So we took this whole NICE workforce mapping and we plugged it into our tool. And then also, like I said, we included an industrial framework as well. So the industrial security framework was built based off of research conducted by McBride at Idaho State University. This was conducted with the use of INL subject matter experts. So the main job roles that they came up with were the following: engineer, design safe and secure industrial systems; analyst, synthesize threat and vulnerability information; researcher, just identify those new vulnerabilities; technician, assure the security and safety of operations; and manager, direct and oversee the general cybersecurity program. And then just like the NICE framework, within these job roles, we have tasks. So all of these have been uploaded to the tool. So now I'd like to do a demonstration of the job task analysis tool for you all. So I'm going to stop sharing this presentation and share the task analysis instead. Okay, so here we see the general overview of the tool and what it does. So this task analysis is designed to walk someone through their job position and then select the categories, specialty areas, roles, and tasks that are associated with their position. So first, you can see we provide a space for the job position. So they may be, for example, they may say they are a business specialist, just like me. They may say that they work in the private government facility sector, and they may work in the critical function area of Connect. Oh, sorry, my screen went dark there for a second. So here we go on to the categories of the NICE framework. So you can see we have these 7 categories, and then we have also added that industrial cybersecurity component as kind of an addendum to the NICE framework for this tool. So when they go through this task analysis, we're not just asking them to come up with, their own definition. They may say, what does securely provisioned mean? So in the tool, you can actually hover over the terms and you can see that securely provisioned means, you're conceptualizing, designing, procuring, and building secure information technology. So as they go through, they can kind of hover over and decide which ones most align with their job. So for example, they may say they do a little bit of securely provision, do a little analyze, and they do some industrial cybersecurity. So now we have the specialty areas based on the categories that we selected. So you can see we've got quite a few under securely provisioned, some under analyze. So again, they go through, they can look at the definitions. They may say they do some technology R&D, so conducting those technology assessments and integration processes. They do a little bit of test and evaluation, threat analysis, and industrial cybersecurity again. Now we have the roles. So they'll go through and select the roles that most align with their job. Now we have the full list of tasks based on the categories, specialty areas, and roles that were selected in the previous steps. So this is the part that takes the brunt of the time for filling out the task analysis. So, they'll go through and carefully read each task and see what makes the most sense for them on a daily basis. So for this example, I'm just going to select a few just to show you how the summary and report functions work. And then next, we also have an option for them to upload any tasks that were not previously listed. So maybe we're missing something, right? So this information goes into our database and then we can make decisions based off of that. So let's say maybe a lot of what they do is they write research proposals. So then they can add that task and we have that information for them. So here's a summary of the roles and tasks that were selected. So we can see here that the greatest percentage that we have is of the threat warning analyst, I believe. So you can see that 6 tasks were checked out of that, so 21 overall were checked. And then a second to that would be a tie for systems testing and evaluation specialist and research and development specialist. We can get more information from the report. This gives that general overview of everything we've learned here. So they are a business specialist. They work in a private government facility. Their main critical function is to connect. We can see that their primary role is that threat warning analyst with 28%. Their secondary role is that research and development specialist at 23%, with that tie for their third role with system testing and evaluation specialist. Also, an interesting part about the task analysis that I haven't yet covered is that we have this competency alignment portion. So this was actually based on the Bloom's taxonomy wheel. So what we did is we went through each of the tasks from the NICE framework and the industrial security framework and aligned those tasks to competency based on the Bloom's wheel. So we can see by the tasks that they selected that they're in some of the higher tiers of competency. At implementation is one of their main. You can see they have, a third role in awareness, and that secondary role is in design. So they're operating kind of higher levels for competency. So that ends my demo here. Go back to the presentation for one more slide, and then I will take questions. So now that we know all of that about the task analysis, what are we going to do with it? So you can use the job task analysis to develop and implement those individual learning paths. You view all possible learning paths from the task analysis. Then you can choose those target training areas based on the data that was shown in that report. So for example, the role percentage is really important when it comes to return on investment, because we would think that the role that they spend the most percentage of their time in, you would want to invest in the most training. So that primary and secondary role is probably where the training will go. Also, you will choose training based on that competency alignment that shows up in the report. So do they need higher levels of training, or do they need lower? Are they just starting out, or are they kind of proficient in that area? So that's what that task analysis will tell you as well. And then they can plan. So from those targeted training areas, they down select to a specific training plan for that individual. And this is how we hope to get the water to the end of the row with industrial cybersecurity, to make sure that the competency of each individual is where it should be. So thank you, and I will take questions from the chat and stop sharing here. Is this tool available to the public? So that's a really good question. We are still testing and validating this tool. We're actually doing some research with a professor to see if he can pick different people in different roles and see if it actually, the results align with what you would expect. So making those hypotheses and testing it and validating it that way. So for right now, it's not available to the public, but it will be shortly.